of what might turn into a series of explainers, which I am imaginatively calling Zach Talks to You About AI, in which I, Zach, talk to you about AI. The purpose of this is to provide some reliable information, fill a little gap out there. I think there's not nearly enough reliable non-technical information that can be used by decision makers and stakeholders in businesses and other organizations that need to make a informed decision about AI and AI strategy. All right, who am I? I have a bit of an unusual background. I have a PhD in philosophy from the University of Wisconsin-Madison. I got in 2002 or 2003. I went the academic route. I eventually became a tenured professor specializing in logic, game theory, theorem proving, confirmation theory, any area that relies on math or logic to understand traditional philosophical questions. That was my thing. I worked, of course, in higher education, but then I quit and started working for a startup. Along the way, I've worked at Argonne National Laboratory's Math and Computer Science Division. I've worked in consulting. I've done some consulting on my own. Plus, I've also worked at a big 5 consulting firm. I've had clients ranging from really old, very traditional banks that needed to get up to date on data science to brand new startups whose whole reason for being was to make advances in their particular relevant areas of AI. And I have been programming since, and this is difficult to say out loud, but since 1982, when I first programmed a Commodore PET computer with 2 kilobytes of memory to find prime numbers. Those were good times. All right. What I'm going to talk about today is machine learning, artificial intelligence, and explainability. In particular, what I want to do is answer the question, what is artificial intelligence as the term is being used today? Is it all hype? Is there something actually distinctive about it? I think the answer is that there's a lot of hype, of course, but that there still is something distinctive about it, and that one of the things we will learn is that the concept of explainability turns out to be super, super important. All right, so a few years ago, in other words, back in the ancient past, we used to talk about machine learning an awful lot. So we had machine learning engineers, machine learning teams, machine learning models, and a lot of that talk has been superseded by artificial intelligence. Now we have artificial intelligence teams and artificial intelligence models and so on. There's a cynical view out there, which is that artificial intelligence is nothing more than a new marketing term for what we've always had before, which is machine learning, and that this is a scheme to attract dollars from venture capital funds. Of course, there is an awful lot of that, but I think that understates where we're at right now. I think there actually is a difference between artificial intelligence and machine learning as the terms are being used today. So let's think about that for a moment. There are a lot of similarities between the two. Machine learning teams and artificial intelligence teams will both create models to make predictions, answer questions, or understand data, very often large amounts of data. And the applications of this are pretty varied, from product recommendation services, movie recommendation services, predictions about whether someone's going to repay a loan, and predictions about whether someone's likely to get into a car accident, and so on. The people skills and tools that you will find on AI teams and ML teams overlap a lot, probably 95% overlap between them. They'll use the same programming languages, usually Python. They'll use a ton of the same tools, and they'll have a lot of the same skills, particularly skills involved in managing, preparing, and training models with large amounts of data. However, there are some differences when you look at how the terms are actually being used today. AI tends to use, quote, big models and big data. Now, what do we mean by big? We just mean, I think, that an amount of data or a model is considered big when off-the-shelf tools are no longer good enough to get it to work. So these are models that require so much storage and so much memory and so much computational power that it takes teams of specialists to get them just to work and to deploy them into production and make them useful. I think once you start getting into the realm of specialization in data and how to manage large amounts of data, that's when you're starting to talk about big data and big models, like these large language models. The main type of model is the neural network for artificial intelligence. Neural networks are used in machine learning as well. But when you start talking about artificial intelligence, you're talking about neural networks 99% of the time. Another distinctive thing about artificial intelligence models is that they're often used on problems that were previously thought to require human skills. So a specifically trained, well-educated, talented human being. For instance, machine translation from one language to another. If you're going to translate from English to Chinese or from Chinese to English, that's obviously something that would require a very skilled, intelligent human being who's been trained and has good education and good judgment, all that. So, and we're also thinking about things like image recognition, reading, radiograph images in a medical context, for example, is something that would require a lot of skill and a lot of training. And we would normally not associate that kind of task with something that could be automated with machine. But it turns out that these recent advances in AI have made a lot of inroads into that. So we're also talking about things like code generation, understanding natural language, carrying out conversations, and so on. Another really important difference that I'm going to harp on a bit here is that when we're in the context of artificial intelligence, we're often talking about models that lack explainability. Now, what is explainability? Explainability is a pretty common sense sort of concept. It is what it sounds like. If your model asserts a fact, can you explain why the model did that? That's what explainability is. So it's a quality that a specific model may or may not have. I've grouped explainability into two different categories. On the one hand, you have what sometimes gets called general or global explainability. And this is when you train a model by giving it a lot of information about a particular problem, and the model is able to determine which kinds of information are important and which kinds of information are not important for understanding that data. If you can interrogate the model and examine it and have it tell you what it thinks is important generally, then we say that it has this kind of general or global level of explainability. For example, suppose you want to create a model that predicts loan defaults. You might feed it a lot of information about potential customers. You might give it their credit rating, you might give it their age, you might annual income, gender, address, location, and so on. And if you train the model and the model seems to work really well, you might interrogate that model and discover that it's weighing the credit rating very highly. It thinks that credit rating is really important for predicting loan defaults, but it thinks that age, for example, is much less important for predicting loan defaults. If you can do that kind of thing, then you've got a model with general or global explainability. Specific explainability is about what it sounds like, specific predictions. So if Alice applies for a loan and it goes through your model and the model says, yep, we should approve Alice, can you ask the model why it specifically recommended approving Alice? And if it comes back and says, oh, Alice was approved because she has an excellent credit rating, then you've got a level of sort of specific explainability. You can understand why specific judgments were made by that model. A crucial thing to bear in mind that I think often gets overlooked by stakeholders when they're talking about machine learning or AI strategy is that not all of these techniques come with explainability. And this turns out also to be a really important distinguishing factor between machine learning and artificial intelligence. Machine learning techniques, as the term is thrown around, usually produces explainable models, as models that almost certainly have some level of general or global explainability. They can tell you what general features of the data it thinks are important. And once you've got that, it's also almost always possible to get some amount of specific explainability where you could interrogate the model and find out what it was keying in on when it made a specific judgment about a specific question, like whether Alice should be approved for her loan application. On the other hand, artificial intelligence models, these very large neural networks, tend to lack explainability, at least for now. I'll get into that in a second. But these tend to be much more like black boxes. When an AI model, one of these large language models or chatbots or code generators or agents, makes a judgment about a particular piece of data or a specific question, it may turn out to give you extremely reliable answers, even insightful answers. But if you go in, you will find that you won't be able to determine why it came up with those answers. What was it looking at? What did it think was important? And it certainly can't do that. It can't do that either in general over all of its judgments for a domain of problem, nor can it do so for specific questions. Now, I've seen kind of misguided attempts to get around this by simply asking the chatbot why it came up with a particular answer, but those introspective questions are not reliable at all. And so that would be a very misguided and cheap way of trying to cheat and get some level of explainability. That just doesn't work. And dangerously, the model will sound like it is giving you a correct answer very confidently, but you should not depend on that. The fact is, these new techniques are black boxes. We do not understand how they work in any deep way. Now, I said at least for now because it would be great and incredibly valuable for so many reasons to try to be able to understand why these models work the way that they do. And as you might expect, there is a lot of research and there are a lot of really smart people working on this explainability problem for AI models. So although it's impossible to predict, I would certainly expect that in the next few years, our understanding and therefore the level of explainability of these models is going to increase quite a lot. All right, so explainability, as you said, is useful for distinguishing between machine learning and artificial intelligence. Is it important? Do you need it? The answer is it depends. Sometimes you may find yourself in an environment where you're actually legally required to use only explainable models. For example, I worked on projects for an insurance company where the insurance company's regulations required them to be able to explain why a particular insurance application has been turned down. As if you were to apply for insurance and the insurance company were to say, no, you're too big of a risk, we're not going to let you buy our insurance, that customer is legally entitled to an explanation as to why. That explanation has to be a lot better than our model said so. It has to cite specific things that went into that specific decision about that person. And so therefore, if they had used a black box AI model, they might be doing wonderful things for their business and they might be getting incredibly accurate and quite lovely predictions, but they would be breaking the law. And obviously that would not be acceptable. But even if you are in an environment like you're recommending movies, and obviously you don't owe anyone an explanation as to why a particular movie would or would not be enjoyed by them, still it can be really useful to have explainable models for a bunch of different reasons. The major one, I think, is that when you have explainability, it makes it much easier for your team to improve the model over time, because no model is perfect. And as a result, they make a lot of mistakes. If you can identify those mistakes and then you can interrogate the model and say, oh, this is why the model made the mistake, this is the thing that it was looking at when it came to the wrong conclusion, then it's much easier to go in and iteratively improve the model. Another reason why explainability can be really useful is that it can help you understand your own data. So, for instance, you might not understand why some people will say default on a loan more than, or are more likely to default on a loan. But if you are able to train a model, that model might key in on certain aspects of their loan applications which you maybe hadn't thought of before. So it might surprise you about what's predictive and what's not, and that will help you understand your own business better. So explainability is super valuable if you can get it. But on the other hand, if you need a chatbot, if you need to do code generation, if you need to do image recognition for medical diagnostics or something of that sort, then you've got no choice. You've got to use one of these bleeding edge AI models. Unfortunately, those are black boxes, at least for now, and you have no choice. You will not get explainability. Of course, if you're in a highly regulated environment and you discover that you need one of these bleeding edge models, then you better come up with a new plan. All right, so takeaways. Machine learning and artificial intelligence just are vague terms. There is no bright line separating them. There is no dictionary definition that gets our current use of those terms right all the time. So if you have been getting the feeling that there's something vague about this and that you are not quite able to put your finger on exactly what the difference is, that's good. That just means that you are a realistic person. But that having been said, the distinction isn't meaningless either. Explainability is a pretty good way to distinguish between them, where machine learning models, as the term is being used today, tend to have high levels of explainability, and AI models, as the term is being used today, tend not to have any significant level of explainability. But that having been said, you can fully expect the goalposts to keep moving. AI especially is a notoriously slippery term. What we mean by AI now has really almost no resemblance to what we would have meant by AI 10 years ago, 20 years ago, 30 years ago, or longer. And it would shock me if a few years from now the term did not change meaning again. So expect this to change. Now, whether you are more interested in machine learning or artificial intelligence techniques is really a pragmatic decision. Your choice depends on whether explainability is important the vast majority of the time. Of course, there are other factors, including cost and so on. But explainability is often at the center of your decision as to whether machine learning models will be of use to your business or whether artificial intelligence models will be of use to your business. All right, and that finishes it up. Like I said, this is an experiment. This is the inaugural video. I am interested in comments about what's useful, what's not useful, how things can be improved, whether there are any questions that would be really useful to talk about, and so on. All right, thank you very much.